I'd like to introduce today's speaker. Rolf is the practice lead for continuous delivery at ThoughtWorks. He has been with ThoughtWorks for 8 years and focused on this space for the past 5 years. He developed his passion for this space in the traditional way, through painful experience as ineffective paths to production, endangered projects he was delivering. He works with a variety of firms ranging from large financial institutions to small companies just out of their startup phase. Today, he's going to give an introduction to continuous delivery, what it is, why people do it, and the key principles and practices that make it possible. Over to you, Rolf.
Thanks, Risha, and welcome everybody to this webinar. As Risha said, this is going to be an introduction to continuous delivery, and I'm going to explain a little bit about what it is, why people do it, and how you can go about doing it. What I want is for you to be able to walk away with a reasonable picture of what continuous delivery is, and some ideas and questions that you might want to go back and ask your organization. To start, I'd like to go back a few years to a project I was working on that actually is the project that led me into this space. This was a broadband provisioning system that we were replacing for an organization. And in the first phase, we were replacing the order capture components. And we did our development. Things went quite well. We were very happy. We were working in an agile method. We worked in 2-week iterations, and after 8 weeks, we delivered a very nice product that seemed to be pleasing to the users that were looking at it. Unfortunately, what we didn't realize was that there was a gentleman who was responsible for looking into how to get this app actually into production. He was sitting over in a corner. We didn't really talk with him that much. And then right around the time that we were wrapping up development, he unfortunately got quite sick and had to disappear, couldn't come into work for a while. And so we all decided to go over and take a look at what he was doing and understand what it meant to release this application into production. And when we looked under the covers, there was quite a mess. There was a lot of things that needed to be done that we hadn't understood. There was a lot of things that weren't really prepared. And in the end, it resulted in a 2-month delay to the actual release of the product, even though the product was, quote, dev complete. And that was only the beginnings of the troubles on this project. The second phase of the project was replacing the order management component on the back end. And unfortunately, the powers that be forgot to budget for hardware. And because of the way that their organization did capital expenses and operational expenses, they couldn't actually go back and ask for that budget. And instead, they had to apply a lot of operational expenses, a lot of consulting to try and solve the problem. And what it resulted in was the organization going out, looking all over the world, scrounging for free hardware, shipping that hardware to a production location in Luxembourg, and setting it up. Because the hardware was scrounged from all over the world, it was very heterogeneous. No two environments were the same. You know, whether it was 2 QA environments or the performance environment or staging or production, they were all built out of different things. And what ended up happening was it was extremely expensive to deploy to these environments. The first time we went into one of these environments, it took 2 weeks to get into that environment. And even a week before we went live, it was still taking up to 3 days to actually deploy to an environment just because of that complexity and heterogeneity. So we kind of looked at this and we said, okay, we want to make this a better world. And we decided to create something that we called Conan the Deployer. And Conan the Deployer was quite simply automation around the deployment and management of environments. It took a CVS tag, it built the application, it pushed that application into an environment, it pulled down WebLogic if necessary, deployed that into the environment, it got configuration for the application and for WebLogic out of CVS, did all of that configuration, and essentially got the environment running nicely with whatever version of the application we wanted. And one of the key decisions that we made that I think was very smart was we went to operations when we decided to do this, and we said, hey, ops, what language, what tool would you like us to use to deploy automation? Operations wasn't really convinced that the automation of deployment was a great idea, but they said, well, we're pretty comfortable with Bash, so why don't you use Bash? And we went ahead and we built the automation in Bash. And over time, we were able to pull operations into the development of that automation, show them how it was working, let them run it in test and QA environments, get them comfortable with it, and eventually they ended up loving it and taking over and believing that it was possible to fully automate this deployment. And what we finally were able to do was move away from a world in which releases in this organization took a weekend and might have had 3 or 4 or even 5 people involved in them to a world where we were able to do releases in 15 minutes at 5 a.m. Somebody would wake up at home, VPN into the company, push something new into production, watch it for 10 or 15 minutes, make sure everything was going well, and then go back to sleep. But what we saw at that organization, what I experienced there was not uncommon. It's what I've seen in many, many organizations. And there really should be a better way to do things. And I hope that I can show you today that there is. Last fall, I had lunch with the Vice President of Operations for Yahoo. So he's the guy who runs Yahoo Mail, Yahoo Messenger, Yahoo News, all of these different properties. And I asked him a little bit about what the purchase of Flickr was like. Yahoo bought Flickr 4 years ago. Now, I'm not sure how many of you are familiar with Flickr. I hope most of you are familiar with it as a photo sharing site. But what's really interesting about Flickr is the way they do development and the way that they manage their products. If you get a chance, go to code.flickr.com and scroll to the bottom of the page, and you'll see a picture just like the one I'm showing you here. This picture shows the number of deployments they've done in the last week of their application and who was involved in those deployments, who built the functionality that was going live. And you can see that in the last week there were 71 deployments to production. So that means that Flickr is going out an average of 10 times a day into production. So that's a really interesting thing. That's very, very different than most organizations. What are the kind of key characteristics behind the scenes here? So fundamentally, what Flickr is doing is that they're working in very, very small chunks. They're building small chunks and pushing them out to production in a very, very rapid way. It results in a constant flow of new features into production over the course of the day, over the course of the week. But obviously, it's not possible to build a feature in an hour. Building a feature might take days or even weeks. So one of the things that they've done behind the scenes is figure out how to do incremental development of features, incremental release of small changes, so that they can actually support this model. The question is why? Why does Flickr do things this way? And there's a bunch of reasons. The first, and maybe the most fundamental, is that they want to make sure they build the right thing. Every idea, every business idea that someone has is really just a hypothesis. As a business person, you're just hypothesizing about what your users want. And you don't really know if you're right until you get real user feedback. And this is the critical idea here. Flickr wants to make sure that they are building the smallest possible thing, the minimum viable product that they can get out in front of users and get useful purchasing feedback from those users so that they know if they're doing the right thing or the wrong thing. Flickr actually didn't start out as a photo sharing site. It started out as a gaming site that had a little side feature that was photo sharing. And one of their big lessons was they learned that it turned out that people really liked the photo sharing feature, not so much the gaming site. And so they changed their entire system to become a photo sharing site. And that was a big lesson that they learned about the value of user feedback and getting that quickly. A good corollary to this is you don't want to waste money on building the wrong thing. It turns out Standish Group did an interesting survey to find out how many features in software are used. And it turned out that 45% of features were never used, 19% were rarely used. So what this means is that most of the money, or a lot of the money that we're spending building software, is just purely waste. If it's not something a user really wants, we just spent money on no value. And there's lots of great examples of this around the world. I'm sure most folks are familiar with the story of Webvan, which was a online grocery delivery company. They had the idea that everybody would want to buy their groceries online, they went ahead and they built a massive infrastructure, 8 or 9 different warehouses behind the scenes, and then when they launched in a massive way. It turned out that folks did want to buy groceries online, but not as many people as Webvan thought, and they quickly went out of business. If they'd started small with something very, very minimal, they probably could still be in business today. Another example is this pizza tracker, which for all I know is actually a brilliant idea by Domino's, but it certainly strikes me as a potential feature that may or may not be used very often by users. It could be a brilliant marketing ploy, though, so I'm not positive that that was a bad idea. The next reason that Flickr and Facebook and other Web 2.0 companies take this approach of doing frequent releases and moving in very small chunks is it allows them to move very, very quickly. It allows them to react to the market very quickly. Obviously, their environment, their business environment changes very fast. If you take a look at Facebook, Facebook is quite interesting. They expect every developer, every new hire developer to write some code and push that code into production on the first day on their job. And imagine if they're able to do that, if every developer can actually get code in production on day one. Just imagine how fast they can react to change. And the reason they do this is obviously to ensure that they're efficient and fast and reactive, but there's actually a second reason as well. They want to ensure that their developers are as close to their users as possible. And this is another benefit that you get from moving to this frequent release process or this short cycle time process, is that development and operations people are going to have to work very, very closely side by side with business people. They're going to have to watch very closely what users are doing, and this is going to help align everybody towards the same business goals. Rather than working in a structure in which there are departments and sub-departments, and each sub-department has different groups that are pointed in different directions and have slightly different desires and slightly different needs, you move to a model where everybody is working more tightly together on a particular product and more tightly aligned with their actual users and the business cases behind them. And this can help make IT no longer the bottleneck when it's very, very close to the business and to the users. It will be able to react faster. The next reason is actually quite interesting. When Yahoo, so I had lunch with the vice president of ops at Yahoo, and I asked him about Flickr, and what he said was quite interesting. He said when they purchased Flickr, they took a look at what Flickr was doing, and they had what I think is a very typical reaction. They said, "Oh my gosh, these guys are a bunch of cowboys. They don't know what they're doing. They're undisciplined. They're just pushing code into production willy-nilly. We're going to have to help them get to a more rigorous, more disciplined place." And so they decided they were going to teach Flickr the Yahoo way of doing software development. And the Flickr folks reacted pretty reasonably. They said, well, okay, before we do that, why don't we go ahead and evaluate, of all of the Yahoo properties, which is the most reliable, including Flickr? And so they did an assessment over the previous year, and it turned out that Flickr was the most stable and reliable product that they had in production. It only went down for a total of 26 minutes over the previous 4 years. And that was a big eye-opener for Yahoo. They kind of looked at it and they said, well, I guess you guys know what you're doing. We don't really understand it, but we're not going to change it, so we'll put you over here in a corner and go ahead and let you do what you're doing because it's working well. And then after a couple years, Yahoo actually changed their mind and said, well, what you're doing is actually great. We understand it a little bit better, and so now we want to try and take the Flickr approach and teach that to all of the other Yahoo properties. So they actually reversed their position. And so why was Flickr very reliable and stable? It has to do with if you release every 3 months, you're releasing an enormous delta of changes, and that means a big, big risk. And usually in that case, something goes wrong in production, when you do that release. And the usual reaction to that problem is to kind of lock down and tighten up and actually release even less frequently. But that's wrong. That's the wrong reaction. What you really should do is actually turn around and start releasing more frequently. You want to move from the left-hand side here, where you're doing infrequent releases, to deploying very, very small changes very, very frequently. And that tends to be lower risk, somewhat counterintuitively, for two reasons. One is because you have a shorter mean time to recovery. And what that means is when a problem happens in production, there are basically two things that need to be done. One is you need to understand the cause of the problem, and then number two is you actually need to fix the problem. And what turns out to be true is that the time to figure out the cause of the problem is much, much larger than the time to fix the problem. And if you have a very small delta of changes going out in your release, the set of possible causes is actually very, very small, which enables you to really figure out the cause very quickly and then resolve it quite rapidly. And so it turns out that that's one of the primary reasons why doing small chunks, releasing in small chunks, can actually be safer. The second reason is that if something is really hard, and everybody knows that releasing software is really hard, if something is really hard, there's a principle that I very much believe in, which is do it early and often, and you'll get really good at it. Which is don't shy away from the things that are really hard, don't avoid them, but actually focus on them and do them again and again and again until they become second nature. I was on a project once where we were responsible for, this is at a large financial organization, and we were responsible for a release of their new strategic investment platform, a very big program of work for them. And we were the release team. We practiced that release so many times that when the actual production release moment came, most of the team went to lunch, and we left one guy behind. He pushed the button, waited to confirm that it all worked, and then he joined us for lunch. It was a complete non-event for us because we had that confidence, because we'd done it so many times. Another reason to look at this approach is because the only true measure of progress is live. The only true measure of being done is something in production. A lot of people talk about being 30% done or dev complete. We certainly suffered from that on the project that I mentioned. But it turned out that usually when you're quoting we're 30% done, we're 50% done, you're wrong. You're not thinking about the full picture, the full cost. I've been on projects in which we had a concept of done, a concept of done, and a concept of done. But it was all meaningless. The only thing that's really done is live. And so if you're getting small chunks out very rapidly, and if you're getting them into production, you're actually starting to measure real progress because you're seeing things that are actually working in production. So let me move on now a little bit to the how. So how do you approach doing things in this way? So the first, most fundamental principle is this one. I believe strongly that what you need is fast, automated feedback on the production readiness of your applications every time there's a change. And this is whether those changes are code or infrastructure or configuration or database or whatever. This is actually a quote from Jez Humble, a colleague of mine who wrote a very, very nice book called Continuous Delivery. Hopefully some of you have had a chance to take a look at that. This is what I spend most of my time doing when I'm working with organizations. I'm trying to figure out how do I get feedback faster on every change. And the reason is that the faster you get feedback, the faster you can fix a problem. If you're a developer or a tester or whatever your job is, if you check in a change and within 5 minutes you find out that there was a mistake, the cost of you fixing that mistake is going to be minimal. It'll take you a couple minutes. If it takes a day before you find out you made a mistake, you're going to have to context switch. You're going to have forgotten what you were doing. You might have evolved the solution from there. It's going to take you a lot longer to fix the problem. If it's 2 weeks later or 3 weeks later or a month later or even 3 months later, forget it. It's going to be extraordinarily expensive to fix that problem. The same person probably won't even work on fixing the problem. They may not be around. They certainly won't remember the context. So what does this fast automated feedback look like? It looks like automating unit tests. It looks like functional testing. It looks like performance testing, integration testing, component testing, all of these things. And it's critically, as it says here in the slide, it's not just around code. Don't just test your Java code. Test every database change, every schema change that you make. Test every bit of infrastructure you're changing. Are you changing the version of WebLogic? Are you patching the OS? Are you changing the way that users are set up on production boxes? Any of these things should be tested, and the feedback should come back very, very quickly. Once you start working towards this secret of fast feedback, what you start to achieve is moving away from this model of releasing every month or every quarter or whatever it is. You start to move towards a model where you're constantly delivering value into production from the beginning of the project. You don't wait 6 months until something goes live. You try and get the first little piece live in a week or 2 or 3 weeks or maybe 4 weeks. Try and get it live as quickly as possible and then start evolving and iterating on it from there and getting that user feedback. And there's 2 kind of crucial benefits here of this rapid automated feedback. One is, and this is really how I define continuous delivery, one is that you have software that's always production ready. You could theoretically press the button at any time and the software could go live. And this allows you to do something very empowering. It allows you to tie releases to business needs, not to IT constraints. So you can almost imagine giving a business owner, your business owner, a button, and whenever they feel like they've got what they want in their minimum viable product, they can just go ahead and press that button, and the software will go live. They don't have to wait for some rollout window. They don't have to wait for some other team in some other location to take ownership and actually push the release out. They just press the button and out it goes. And critically as well, you're minimizing the lead time from idea to live, and this is allowing you to do this reaction to user feedback very, very quickly. So you're moving from a world, and this is really a change in the way that business works. You're moving from a world in which the business has a few ideas. They evaluate them. They have to choose 1 or 2 ideas, and they invest in them for 6 months, and then they go live and they see what happens. You move away from that world to a world where the business has a few ideas. Maybe they decide to try 3 or 4 of those ideas. They invest 2 weeks in them. They get something out there, and they start to get that real feedback on it, and they start to then cull the bad ideas, modify the good ideas, and move on from there. So how do you actually go about changing an organization? Because this is not a minor change. This is a really fundamental change to organizations. So what's the first step? There's a philosophy that I believe strongly in called systems thinking. And basically what systems thinking says is that you can't look at individual components in a system and try and optimize them in isolation. You have to optimize the system as a whole. And I think this is really, really true of software development. And there's a tool that is aligned very well with this approach that I like to use when I start looking at an organization to understand how to make improvements. And it's called value stream mapping. This is a tool that was created by Toyota as a part of their lean approaches to manufacturing. It's the way they improve their processes, manufacturing and supply chain processes. And basically what value stream mapping is it's a tool that you map the steps from having some idea, from having a customer request until that request is fulfilled. You look at all those steps, you gather some quantitative data on how they're working, and then you try and improve the whole, not just the individual steps in isolation, but you actually try and improve the whole. This is a quick picture of a sample value stream map that has some of the components that many organizations have in their value stream. So you might have product discovery, product definition, coding, automated testing, integration testing, UAT, and release. And what you can see is I've gathered a few metrics to try and understand each of those different phases. And you can see lead time is the amount of time that some idea spends in that step. Value add time is the actual amount of useful time in that step. So how much real work is being done in that step. So for example, in product discovery, it might spend 2 months in discovery, but there's actually only 2 real days of work being done there, and then the rest of the time is essentially wait time. And the last metric is complete and accurate. So what percentage of things coming out of this step are actually good for the next step? How much rework might need to be done? So this approach is the standard way that I look at organizations. So what I try and do is I try and get all of the different stakeholders in this value stream together in a room, and you can see this will range from the business to analysis to development to testing to operations. It may even include folks like compliance and security. Get all those folks in a room and have them map out this value stream as they understand it. What you'll usually find is that different people in the organization actually have different pictures of the value stream, and they don't really actually understand their impact on each other very well, because often they'll be working in silos. They won't actually be talking as much as they perhaps ought to. And actually, you'll even find just in the exercise of mapping the value stream, people will start to come up with ways to make improvements. Oh, I didn't realize that I was impacting you by doing that. I could do this other thing, which will save you a lot of time. So as you go through value stream mapping, what you generally do is get the folks together, map out the current state, have folks identify what the real key problems are in that value stream, where are the biggest issues, and then draw out a future state of how things might look improved, and build a roadmap of about, say, 3 months of improvements, low-hanging fruit. What are the things that are going to get us the fastest value? How are we going to improve this value stream the most over the next 3 months? And then you can iterate on it again. This is, of course, all about continuous improvement. You're not going to jump from this kind of a value stream to pushing live 10 times a day, and maybe you don't even want to. But you can make improvements over 3 months and take a look at it again, decide what you think should be improved, and work some more. You're never, ever going to be done with this improvement. Now, I'm only going to talk mainly about the coding, from writing code and checking it in until we go to release for the rest of this talk. It turns out that this space is extremely important and often highly undervalued in making a value stream efficient. And so I find enormous amounts of things that you can do in this space that will reap massive benefits for you. So very quickly, I'm going to go back to the year 2000. For you non-techies out there, don't worry, this is the only code quiz that I'm going to have in this webinar. But take a look at this code, and I'm hoping some of you recognize it, and I'm hoping some of you actually do this in your organization. So this is back in the year 1999 or 2000, ThoughtWorks implemented this little loop here. And what this loop does is every 60 seconds it wakes up, it checks source control and says, hey, has anything changed? And if it has, it goes ahead and it checks out the application, it compiles it, it builds it, and it runs all the tests that it can run, and it reports back the results. So this is actually the first implementation of continuous integration. And to take a look at what continuous integration looks like, to step back and take a look at the practice of continuous integration itself, what it's all about is having a bunch of developers checking all of their changes into one place, into one source control, having some kind of a server observing that source control, and when it sees changes, checking things out, building, running tests, and then reporting back green or red. The critical bit here is that everybody's sharing the same source control, and that you're building on every check-in, and that you're testing extensively. And what you get out of this is really two big things. One is you get that rapid feedback. This is step one in getting rapid feedback. If as soon as I check in, I can get that feedback 5 minutes later, it's going to be easy for me to make a fix to what I did if I made a mistake. And then the second one is you're getting early integration. You're getting everybody's changes happening in the same place right away, and that helps you to tease out issues early and to reduce risk. But continuous integration is only really step one in that pipeline from checking in some code until that code goes live. And these principles of rapid feedback, I know I'm repeating myself, but this is the core principle, rapid feedback and early integration can be extended very naturally to the rest of the deployment pipeline. So this is a picture of what a more complete deployment pipeline might look like, from a developer doing builds locally to checking in to running some fast continuous integration tests to running some slow continuous integration tests. And the critical thing about this picture is that the further to the right you are, the slower your feedback. And the further to the left you are, the faster your feedback. And so a lot of what I do in organizations is I try and understand this pipeline, and then I try and push as many things to the left as I possibly can. So how do I get those performance tests away from being so far to the right? how can we run some performance tests earlier? Can we automate some of the simpler ones? Can we run them as a part of continuous integration? How do we get those manual functional tests further to the left? Can we automate them? Can we rewrite them as unit tests? Do they really need to be functional tests? Can we get them to the point where a developer can run them on their desktop or a tester can run them on their desktop? Because that's the fastest possible feedback. Continuous integration actually isn't the fastest feedback. It's developers and testers being able to run things locally. Now, with a deployment pipeline, what a deployment pipeline really is, it's an automated implementation of your system's build, deploy, test, and approval processes. So, and it doesn't mean that every step in the pipeline needs to be automated, but it does mean there's a lot of value in actually automating the promotion process between those steps, so that you actually can watch a build progress from being checked in to being built to being continuously integrated to being manually tested, to being signed off, to being pushed into production. And some of the key benefits you get out of it are visibility. So you start to be able to see where things are going and what things are happening. So as a tester or a developer, I can see what happened to my change. How far did it progress down the pipeline? Did it impact other people in the pipeline? Did I break things? Are other components dependent on me and I didn't realize I had broken them? But if I can take a look at an automated pipeline, I can actually see, I can trace my changes and see where they impacted things. You also get traceability back to, or you can get traceability back to requirements. So you can start to see, if there's a requirement and when somebody checks in a change, they reference that requirement, you can start to see, oh, this build contains these sets of changes which map to these particular requirements. You can start to see what exactly is progressing down your pipeline. And critically, and this is actually one of the main challenges or objections that people have when they first hear about continuous delivery, is they worry about compliance. And I'll actually make the claim that continuous delivery will get you more compliance than you've ever had before, because you're working on making this deployment pipeline that is actually tracing everything moving from a check-in into production. And so you're actually able to map things to who made a change, what change was made, why did they make the change. All of those questions start to become essentially a database query. And that's a very, very powerful place to be in. So underneath a pipeline, there's a lot of core practices that support making this possible. And one of the most fundamental is treating everything like code. So what do we do with code? We check in code, we automate its build, we test it, we'll promote it through a deployment pipeline into production. But there's a lot of other changes that go into production that are not code. For example, database changes, DDL and static data. So that stuff should be checked into source control as well. Its build and deployment should be automated. It should be tested too. Deployment automation itself should be checked into source control, should be versioned, and should be promoted along with the version of the system, the version of the application or the system's configuration that it maps to. Infrastructure and configuration management. This is a bit of the new world. A lot of folks are starting to do this now, taking a look at, how do I configure my machines? Like I said, what OS patches are on there, what users are in there, what packages are installed. All of that kind of configuration can now be encoded in some nice languages like Chef and Puppet, checked into source control and follow the exact same pattern as Java code. And potentially even monitoring configuration. When you're developing features and those features require new changes to monitoring, wouldn't you like to test those changes in QA? Wouldn't you like to be monitoring the same way in QA and understand its impact and then promote it up to production once you're confident you've got the right monitoring in place? So monitoring configuration is actually something you can consider doing the same thing. It's just another change to production, just another thing to check into source control, automate, test, and promote. A close corollary to that is moving towards treating your servers like cattle, not like pets. If you name your servers, and a lot of folks do that, I consider that to be an anti-pattern. We name our pets. We don't want to name our machines. you start to get attached to things that you name, and you don't want to get attached to servers. You don't want to do anything manually to servers. Actually, you don't even ever want to really touch them. As much as possible, you want to automate all changes that are made on them. There's a gentleman named John Willis who had a great quote. He said that if you log into a server to make a change, you're probably doing something wrong. What you want to do is you want to make that change in code. You want to check that code in, validate it, and then promote it into that environment, just the same way as you do with all your other code. You might even go to the extreme of considering to do a kill and fill approach to your servers, in which rather than upgrading your servers and making changes to your servers that are live, every time you need to make a change, you might actually build a new server. Obviously, this works best with virtualization. Build a new server and then swap the new server in for the old server in production. And what you do then is you guarantee that every change that's being made is being checked into source control. You guarantee that you have that traceability and you know exactly what's going on your servers. What you don't want to do is end up with a bunch of special snowflake servers where each server is a little bit different. They've been manually managed. Maybe sometimes the sysadmin forgets to do one step on one server or has to tweak one server in a special way. And so all of your servers start to diverge. And they may be diverging in a given environment. So you might have 20 production servers, each of which is starting to look a little bit different and a little bit special. Or it might actually be between environments. You don't want your production servers to look different than your QA servers, do you? And so you want to move away from that kind of thinking. Don't log into servers. Do everything through checked-in code. Ensure that you are confident that all of your servers are the same and that you know exactly what's on those servers. Another critical principle and practice behind continuous delivery is adhering to this test pyramid. This is a fantastic pyramid from Mike Cohn, Lisa Crispin, and Janet Gregory. And basically what it shows you is at the bottom tier there are unit and component tests, very fine-grained tests. The middle tier is acceptance tests, maybe more functional. And at the top level, you have some GUI tests, which are actually driving the GUI to validate that the GUI is working correctly. And I guess even above that, there are some exploratory and manual tests. The thing about the pyramid is that the further down the pyramid you are, the lower the cost of writing the tests, the easier the maintenance of those tests, the less flaky they are. Unit tests are very, very stable. Functional tests tend to be quite flaky. And the further down the pyramid you are, the faster the feedback. There is a project that I've worked with that has, I think it's 7,000 unit tests that run in 12 seconds. That is an enormous amount of feedback, and you're able to do that very, very quickly because you're testing at the unit level at a very fine-grained level. When I go to most organizations, I don't see this pyramid picture. What I often find is an inverted pyramid in which most of the tests are done at a GUI, through the GUI of functionality, and they have a precious small number of unit tests. And what I recommend to those organizations is really trying to taking a look at what you're testing at the functional level and at the GUI level, figuring out if it's really a functional or a GUI test, figuring out if you can't do it some better way. Can you at least test the functionality through an API instead of through the GUI itself? Or is actually what you're testing just a unit test, and it's not necessary to have a large, onerous functional test or GUI-based test driving out that verification? There's enormous value in this, and especially as you're starting to move to a continuous delivery approach, you need your tests to run quite quickly. If you're pushing to production quite regularly, you can't wait for a week's worth of tests. You can't really wait maybe even for a day's worth of tests, depending on your frequency. You want these tests to run very fast. Now, you can't make everything a unit test because fundamentally, the further up the pyramid are, the more business-like, the more realistic your tests are. And so there is a bit of a trade-off here. You will need some GUI tests. You will need some acceptance functional tests. But try and minimize the amount of those tests that you need. This slide is generally the most controversial. What I tend to do when I talk to organizations is I'll ask them how many of them are doing continuous integration. And the majority of organizations nowadays are doing some continuous integration. It's a little bit of old hat. So everybody will put up their hands, and I'll say, okay, well, why don't you go ahead and put your hands down if you don't check into mainline at least once a day. And, a fair number of hands will go down if they don't check in at least once a day. Not necessarily mainline, actually, just check in once a day. And then I'll say, okay, well, why don't you go ahead and put your hands down if you use feature branches that aren't merged into mainline at least daily. And in most organizations, almost every hand will go down at that point. And what the difference here is, it's the difference in thinking between continuous integration as a tool and continuous integration as a practice. Continuous integration as a practice is really strongly about integrating all the changes as quickly as possible. If people are working on feature branches and they're not merging back and forth very, very often, they're not doing continuous integration. They're working in separate silos. The tools out there, the continuous integration tools out there, are really build automation tools. They don't give you the practice out of the box. All they do is they automate your build. And build automation and test automation is different than continuous integration. There are some other kind of fundamental issues around branch-based development, which is why I'm a pretty strong advocate of moving towards trunk-based development. Some of those issues are that branching really discourages refactoring. And what happens is when people are working on branches, they may be working on the same code that other folks are working on other branches. And as that starts to happen, people start to get very nervous about making changes to that code, to refactoring that code and making improvements. And the reason is because they don't know what the other folks are doing. They can't see that. It's not being integrated into their changes. And so therefore, they run a risk of paying a very, very high cost when merge time comes. And it turns out that the other folks went in a different direction. And the merges have to be done manually and require a lot of thinking to get it done. So you tend to discourage refactoring. You tend to discourage people from constantly improving the code. Branches obviously delay integration and hide risk. If you're working in isolation on a branch, no one else can see your changes. Even if you're merging from trunk, it doesn't matter because other folks can't see the changes that you're making and the risks that are inherent in that. And of course, merging wastes time and it's tedious. I've been on projects where we've had to rotate who's been doing the merges. It's a very painful, unpopular task. People hate it. It saps morale. It's not something that you want to force your people to do. There are a couple challenges, though, around trunk-based development, a couple concerns that people usually have when we talk about it. One is, well, how on earth, if I'm doing trunk-based development and I'm releasing regularly or frequently, how on earth do I build a feature? Because I can't necessarily build the feature fast enough for the next release. I might only be partly done. And that's a very valid concern. And there's a couple great approaches to it. One is using feature toggles. And feature toggles are very simply, they're just little flags in the code that turn on and off incomplete features. So as you're developing a new feature, you'll put in a flag that keeps the old feature on, and then once you've completed your new feature and you're confident in it, you can swap that toggle and turn on the new feature and turn off the old feature. I was working with one organization in which every story they developed, the first task was to build a flag, a feature toggle, to toggle off that feature until it was ready to actually be turned on in production. One thing you need to be very, very aware of with feature toggles, though, the most common mistake that folks make is that they don't delete their toggles and they don't delete the old code when they're done. And this is very easy to do because once your toggle has been switched to the new feature and it's live in production, you want to move on to the next thing. The business wants you to move on to the next thing. There is a small cost to deleting that toggle and deleting the old feature, and so people will skip that step. And what you end up with is combinatorial explosion of complexity as you start to get more and more pass through the code and more complexity to making any change you want to make. So it's really important to actually go back and delete the toggles and delete the old code. The second kind of challenge that people face around implementing partial features is more around architectural changes. Toggles are often done at the UI level to turn features on and off at that level, although they can be done in a middle tier as well. But if you're making a massive architectural change, that might take weeks or months. And so you're going to need to figure out how to do that. And there's a nice pattern called branch by abstraction that will help you out. ThoughtWorks has a product called Go. And as we were developing Go, we initially used iBatis to do the persistence and decided to change to using Hibernate. And so in order to make that change in an incremental way and keep the application always production releasable, we implemented an abstraction layer, a persistence abstraction layer above iBatis. And then one object at a time, we started switching its persistence from iBatis to Hibernate. So we actually had two implementations underneath the persistence abstraction. One was iBatis, one was Hibernate. And we were able to kind of switch one object at a time from iBatis to Hibernate. And we actually released this product, did a full product release to the world in the middle of this change. So you had some objects being persisted by iBatis and some objects being persisted by Hibernate, and it worked pretty well. And then, of course, at the end, once everything was in Hibernate, we deleted the iBatis implementation and the persistence abstraction. The next key practice here is having consistency from development to production. Often you'll find that development and QA and production environments have a lot of variance between them. They're not at all similar. And the majority of that variance I find is what I call accidental inconsistency. So it didn't have to be inconsistent. It just kind of worked out that way. There are cases where there's necessary inconsistency. For example, the scale of your production environment is going to end up being larger than your other environments most likely. But the majority of the inconsistency tends to be accidental. It may be a result of siloization of the organization where different folks are managing those environments differently. It may simply be the chance of the individual who's actually modifying those environments. It may be because you're doing things manually and not automated. And so things are just naturally going to diverge or devolve over time. Some of the key things that you want to keep consistent are deployment process. So you want to deploy the same way in development that you deploy in QA that you deploy in production. Like I said, when we built Conan the deployer, one of the things that I was proudest of was actually implementing it in Bash because that's what the ops team would use in production. We wanted to make sure that we were using the same exact tooling and the same exact process. Environment configuration, again, often you'll find different groups managing the environments differently. You want to keep, as much as possible the same OS, the same packages, the same way that you're actually managing that configuration. And you actually want to make those configuration changes, check them into source control, and promote them through your deployment pipeline. Even testing tools can vary between environments. I often see a QA group using one tool and then developers not using that tool and maybe not even having access to that tool. Often that'll be because of the way that licensing can work around some of these tools. If the licensing cost is very high per user, it'll be given to the QA group, and the QA group will run the tests. And what happens because of that is a lack of communication between development and QA, a lack of a shared understanding of features, and critically, you really hinder rapid feedback. If a developer can't run the test on their desktop, then they can't get feedback as fast as they should. If it doesn't run in CI, they can't get it as secondly quickly as possible. If it's being run by a QA group and that QA group runs regression once a week, well, now you're suddenly in that situation where a developer makes a change and waits a week before they find out whether it worked or not. You don't want to be in that situation. You really want your developers and your testers to be sharing the same exact tools. Another critical step here is pulling IT operations onto the delivery team. You want them to be sitting together with the business, with development, with QA. You want those sysadmins in the same exact place because otherwise you're not going to be able to move to this very small chunk rapid cycle. There is going to be a need for all of these folks to work very, very tightly together because you are constantly releasing into production. You're constantly involving all of these different groups. And one of the critical things you want to look at is actually take a look at the KPIs with which you're measuring and incenting your organization. Often what you'll find is development is measured on and incented for making change. How many new features can you put into production? Whereas operations and sysadmins are measured and incented on stability. What is the uptime of our application in production? And this immediately puts them in conflict, and for no great reason. And the conflict is the easiest way to maintain stability is to allow no change. And so, of course, systems admins and operations is not going to love the idea of new changes coming at them because it's just a risk to their incentives and to their measures. What you want to do then is take a look at those KPIs and share them between these groups so that the development group is actually measured on stability and is responsible for stability. There are a lot of decisions development groups make that have massive impact on stability that operations has no influence over whatsoever. They should be measured on stability as well. And by measuring them on stability, you will tie them closer to operations. And vice versa, operations should be measured on change. How many new things could you get into production? How much new business value could you add to the organization? That is a big deal that operations is heavily involved in. You can move to having operations using the same story walls and the same iterations as the rest of the delivery team. I worked with one organization in which, as the delivery teams, the development teams became more and more agile and started producing more and more stuff to put in production, the infrastructure team became overloaded. And they stepped back and decided to re-look at how they were working and better align themselves with the development teams. They actually did exactly this. They embedded themselves onto the delivery teams, sitting right next to the business owners, learning what those business owners cared about for the first time because they'd been so far removed previously in the IT operations dungeon that they really hadn't understood what the business was all about, what the business was trying to get at. There was a few challenges that they faced. It hasn't been simple. One of them is that IT operations tends to have a lot of specialization. You'll have your network specialist, you'll have your server guy, your storage folks, your database admins, all these different folks with strong specializations. And the challenge is, well then, if you need a little bit of each of those on those delivery teams, but you don't really have 1 million people in IT operations, how do you map that? And the organization I worked with, they actually built little mini teams, mini cross-functional teams. So they have a storage person, a server person, a network person, whatever, on a little mini team, and that mini team would then support one or more delivery teams and embed themselves on those teams and go sit with those teams, perhaps rotating on a daily basis between the teams if they were supporting more than one team. One of the challenges they faced when they did that was then they started to lose the functional tie between the network admins. They weren't talking as much as before because they weren't sitting together in a group. So then they moved to a model where they sat together, every an afternoon twice a week to make sure the network admins were all talking and sharing context as well. So they all had to work with laptops. They were moving every single day, sitting in a new place, sitting with the folks that were most important to sit with at that time. And actually what this organization really decided was that the nature of IT operations is changing, or the nature of their IT operations is changing. And I think this is actually a general trend. Historically, IT ops has deeply valued specialization. I'm a network admin level 7. I can do anything. But what they found is because the requests, the needs coming out of these delivery teams were not consistent. You didn't have the same amount of need for network admins every week. You didn't have the same need for storage folks every week. One week would be lots of storage work. The next week would be lots of network work. So what they really needed were generalists, people who could do a little bit of everything. And so that organization is now moving to make all of their IT operations staff into generalists, and then certainly retaining some deep specialization, but not focusing entirely on specialization. And they think that these are the folks that are going to be paid the most in the future in IT ops are the generalists, not the specialists. So that's about it for the practices. There are a few different concerns, some of which I've already covered, but I want to kind of review them really quickly. Concerns with moving to continuous delivery. Make sure that I've talked to them a bit, and then we can move to questions and answers. Reliability and stability, I think we've talked a good amount about that. Moving to small chunks has this counterintuitive effect of actually making things more reliable and stable. Compliance and traceability, again, if you have this automated deployment pipeline, you have amazing compliance and traceability. releasing 10 times a day, it is not necessary to release 10 times a day. Continuous delivery does not prescribe releasing every check-in or anything like that. What it says is you want to have always production releasable code. You want to make sure that you've validated it as much as possible so that you're confident in it every day, and then release it when the business situation warrants it, when it makes business sense to release it. Complexity of my system. So a lot of organizations will say, well, Flickr is just a site where you share vacation photos. It's not as complex as my organization, and I think it's true. It is not as complex as large financial organizations or other kinds of organizations. And so I don't think everybody will ever get to the point that Flickr has gotten to. The point is that you can make improvements, though. You can take your cycle time, which may be, I've been in financial organizations where the cycle time is 9 months. You can take that 9-month cycle time and you can start to fix it. You can start to improve it. You may never get to a 1-hour cycle time, but maybe you can get to a 2-week cycle time. Maybe you take the 9 months and you say, I want to make it 5 months. Okay, great. Now I want to make it 3 months. Now I want to make it 2 months. Now I want to make it 1 month. And maybe that's enough improvement for you, or maybe it takes you quite a while to get there, and by the time you get there, you've seen a completely different change in your world. The key thing here is start with low-hanging fruit and look at it as a continuous improvement. Just try and get better than what it is today. Just try and make improvements over where you are today. Take a look at maybe, go from 9 months to 4 months. Whatever your situation is, try and make that improvement first. Once you've made that, then go back and reflect again and see what the next improvement should be. The last concern is it will take investment, and my answer is yes, it will. You're not going to be able to make this change without making some investments. It is going to change the organization as a whole as well. What I would expect to see, though, is you should start seeing dividends fairly early. If you're making large investments and you're not seeing improvements for quite a while, you should stop and you should reflect on that and investigate what's going on. It will take some investment, but you should start to see dividends coming reasonably quickly. Before I go to Q&A, actually one more thing. This is a question that I'd like you to take back to your organization. Very simple question. How long will it take to get one line of code changed into production using your normal process? This is not your emergency bug fix process. This is your just normal process. How long will it take you to just change one line of code and get it into production? And what are the constraints that are holding you back around that? I think that's a critical key question that you can start using to look at your organization.